Hello everyone, in today's experiment we'll be investigating the Snell's law of refraction, which states that the ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant to a given pair of media. Mathematically, it is expressed as sine I over sine R is equals to n. N is the refractive index. So for this experiment, we are making use of optical board, the rectangular prism, the ruler, your compass, of course, to measure the angles, the optical pin, the optical paper, and the thumb pins to fasten the paper on the optical board. So let's get started. Place the rectangular glass prism on the optical paper. Let it be close to the middle. Place your hand firmly on it and trace out its outline. Label it A, B, C, and D. To draw the normal, place your protractor on the line AB. Make sure the 90 degrees mark is not on the middle. It's not at the middle. Place it close to the middle, but not at the middle. Put a dot on the 90 degrees mark, and on this mark, remove your protractor. Use a ruler to join the 2 points together. The perpendicular line to AB serves as your normal. Label it NO. Put back your protractor to measure the 30 degrees, which will serve as the angle of incidence. You know, the angle of incidence is the angle between the normal and the incident ray. This is 30 degrees. Put a dot on it. Join that dot to the center O with a straight line. This line serves as the incident ray. You use an arrow to indicate it is an incident ray. Mark 2 points on the incident ray. Call the first point P1 and the second point P2. We put 2 pins there, the optical pins. Make sure that they are vertically erect, and they should be at least 4 centimeters apart from each other. Replace your rectangular prism and view through CD. While viewing, you can close one eye and look through it in such a way that you'll be seeing 1 pin instead of seeing 2 pins, which means that the 2 pins are aligned. Use the 3rd pin to place on it. Make sure that you are not seeing 3 pins, rather you are seeing 4 pins. Use the 4th one to block the other ones. In such a way, you are seeing only 1 pin instead of 4 pins. Having done that, remove the 2 pins and mark the 2 points as P4 and P3. Remove the rectangular prism. Join the 2 points to CD with a straight line. Then, to get the normal of CD, place your protractor at this point, which is Z. Place your protractor there and mark your normal. Put a dot here and another dot on the 90 degrees mark. Then join both marks with a straight line. Then call this other point R. So RZ serves as your normal. Remember that this ray is called the emergent ray. And this angle here, the angle that the emergent ray makes with the normal, is called the emergent angle. We denote it with a small letter E. You put the dot there to show that it's an angle. Then join O to Z with a straight line. This straight line serves as the refracted ray. Remember that refraction is the bending of light ray when it passes from one medium to another. You can see it's bent in. So this is the angle of refraction. An angle of refraction. Then place your protractor on the emergent angle to measure the emergent angle. Then from here, what did I get? 90, 80, 70, 60. So this is 34. So angle of emergence is 34 degrees, and the angle of refraction is 10, 20. So this is close to 20, which is 19. So for this experiment, the angle of incidence is equals to 30 degrees, and the angle of refraction is equals to 19 degrees, and the angle of emergence is equals to 34 degrees. You can go ahead to do for other values of I, 30 degrees, 90, 40 degrees, 50 degrees, 60 degrees, 70, as the case may be. Thank you for watching, and you can give us a thumbs up and don't forget to subscribe. Thank you.